Howdy, stargazers, and welcome to this episode of Star Trails. My name is Drew, and I'll be your guide to the night sky for the period of July the 5th through the 18th. This week we explore a wild theory. Maybe Planet 9 isn't an object in the outer reaches of our solar system, but a strange relic of the very early universe known as a primordial black hole. Science supports their existence, but actually finding one may be like searching for a needle in a haystack if that haystack was thousands of miles wide and the needle was invisible. Later in the show, we'll celebrate an upcoming new moon with a look at what you can expect to see in the night sky. And keep in mind, we're still on our summer publishing schedule, so through August, new episodes drop every 2 weeks. If you're a new listener, you may enjoy looking through the back catalog, and be sure to check out the show website, startrails.show. Hit the Start Here link up top for a list of my favorite shows and resources for astronomers. Whether you're tuning in from the backyard or the balcony, I'm glad you're here, so grab a comfortable spot under the night sky and let's get started. For centuries, we've imagined the solar system as something finished. 8 planets, a few dwarf planets, asteroids, comets, case closed. We put it on classroom posters, memorize the order of the planets, and move on. But nowadays, we think that map may not be quite complete, and the math seems to confirm it. It's a tale we've heard before. In the early 1800s, astronomers noticed that Uranus wasn't behaving exactly as expected. Its orbit seemed to be just a little off, as though something unseen was tugging on it. Rather than assuming the calculations were wrong, 2 mathematicians working independently reached a bold conclusion. There had to be another planet farther from the Sun. Using nothing more than Newton's laws of gravity, they predicted where that unseen planet should be. When astronomers turned their telescopes toward the predicted location, they found Neptune, almost exactly where the math said it would be. It's one of the greatest detective stories in science, and it's had a few sequels. If one unseen planet could reveal itself through gravity alone, could there be another? For decades, astronomers searched for a mysterious planet X lurking beyond Neptune. That search eventually led to Clyde Tombaugh's discovery of Pluto in 1930. For a time, some thought the mystery had been solved. But Pluto turned out to be much too small. It simply doesn't have enough gravity to account for the strange motions astronomers had hoped to explain. As the years passed, we found more distant worlds, icy bodies inhabiting a vast region beyond Neptune known as the Kuiper Belt. Eris, Haumea, Makemake, Sedna, all fascinating discoveries, yet none of these objects seem to be the answer. Today, the mystery has returned under a different name, Planet 9. Several of the most distant known objects in our solar system follow oddly clustered, elongated orbits. It's almost as if something massive and unseen is quietly shepherding them from the darkness, hundreds of times farther from the Sun than Earth. Some astronomers believe these unusual orbits continue to point toward a large undiscovered planet. Others argue the apparent pattern may simply be the result of observational bias. In other words, we've only found the objects our surveys are most likely to detect. But recently, a far stranger possibility has entered the conversation. What if Planet 9 isn't a planet at all? What if the invisible object tugging at the edge of our solar system is something that has been wandering the cosmos since almost the beginning of time? A tiny black hole, not the remains of a dead star, but a relic from the birth of the universe itself. The words black hole always conjure up a certain image. Maybe you picture a dying star collapsing in on itself. Maybe you imagine a swirling disk of glowing gas disappearing into a dark abyss. Or maybe you've seen one of those famous artist's renderings where light itself bends around a pitch-black sphere, and ordinarily you'd be right. Most of the black holes we know about began their lives as stars. Massive stars live fast, burn through their nuclear fuel, and when they die, gravity wins. Their cores collapse into objects so dense that not even light can escape. And those are called stellar black holes. But what if I told you there may be another kind altogether? To understand them, we have to travel back almost 13.8 billion years to a time before there were stars, galaxies, or planets. The early universe wasn't filled with suns and worlds. It was an unimaginably hot, dense sea of energy and particles. Matter hadn't assembled into the grand cosmic structures we see today. Everything was compressed into a universe so young that time itself had barely begun ticking. Now imagine that this newborn universe wasn't perfectly smooth. Imagine tiny wrinkles, regions where the density happened to be just a little higher than the space around them. Some theoretical models suggest that under just the right conditions, a few of those regions could have collapsed under their own gravity almost immediately. Instead of forming from the death of a star, these black holes would have been born directly from the chaos of the Big Bang itself. Astronomers call them primordial black holes. If they exist, they would be among the oldest objects in the universe. Let's put that into perspective. Our Sun is about 4.5 billion years old. Earth formed shortly afterward. The dinosaurs appeared only a couple 100 million years ago. Human civilization is barely a blink of an eye. But a primordial black hole could have existed before the very first star ever lit up the universe. Now, here's the part that really stretches the imagination. When we hear the words black hole, we tend to think big. But black holes aren't defined by their size, they're defined by their mass. If you could somehow compress the mass of several Earths into an object no larger than a bowling ball, gravity would take over completely. The object would become a black hole. Its mass wouldn't change, its gravity wouldn't change, only its size. It's one of the strangest ideas in all of physics, an object carrying the mass of multiple worlds hidden inside something you could almost hold in your hands, even though getting too close to it would instantly become the last mistake you ever made. Now, I've been watching a lot of professional bowling on TV lately for some reason, so the idea that the mass of 3 or more Earths could be crammed into something you could chuck down a bowling lane is intriguing. By the way, that ball would weigh, about 18 septillion kilograms or so. That's an 18 with 24 zeros behind it. The pins wouldn't have a chance, and neither would anything else near it. But back to the mystery at the edge of our solar system. Could something that ancient, compact, and invisible be quietly orbiting the Sun hundreds of astronomical units away, revealing itself only through its gravity? So let's suppose, just for a moment, that there really is a primordial black hole lurking in the outer solar system. How would we ever find it? After all, that's the whole problem with black holes. They're black. They don't shine like stars. They don't reflect sunlight like planets. You can't simply point a telescope toward the darkness and wait for one to drift into view. Instead, astronomers have to become detectives. Of course, the evidence they collect isn't fingerprints, it's gravity. Gravity is invisible, but it leaves clues because we can see its effects. It's the reason planets orbit the Sun, it's the reason our Moon circles Earth, and it's the reason entire galaxies hold together. If an unseen object has enough mass, it announces its presence by tugging ever so slightly on everything around it. That's exactly how Neptune was discovered, and it's exactly why astronomers are still searching for Planet 9 today. The distant icy worlds beyond Neptune aren't scattered randomly through space. Several of the most extreme objects we've discovered seem to share oddly elongated, similarly oriented orbits. It's as though something massive has spent millions of years gently nudging them into place. Picture leaves floating on the surface of a pond. You never see the fish swimming beneath them, but if all the leaves suddenly drift in the same direction, you know something underneath the surface must be moving. That's the kind of evidence astronomers are studying. They're not looking at the invisible object itself, but rather the ripples it leaves behind. We've found thousands of planets orbiting distant stars without ever seeing most of them directly. Instead, we watch the parent star wobble ever so slightly under the pull of an unseen planet. Sometimes we detect a tiny dip in a star's brightness as an invisible world passes in front of it. We've mapped enormous reservoirs of dark matter, not because anyone has seen dark matter, but because galaxies rotate far too quickly to be held together by visible matter alone. Even many of the black holes we know about were discovered because they were feeding on nearby gas or pulling on companion stars. But here's where the primordial black hole idea becomes even stranger. A planet reflects sunlight. Even if it's dim, eventually a powerful enough telescope might spot it. A primordial black hole, on the other hand, reflects nothing. There would be no disk, no atmosphere, no clouds, no sunlight glinting from an icy surface, just darkness. If one really is orbiting far beyond Neptune, it would be among the most elusive objects we could possibly imagine. And yet, even perfect darkness can't hide from gravity. If Planet 9 is a planet, then sooner or later, someone should find it. It may be incredibly faint, it may take years of searching with the largest telescopes on Earth, but planets reflect sunlight. However dimly, they can eventually give themselves away. A primordial black hole is another matter entirely. You could point the world's largest telescope directly at it and see nothing. So astronomers have begun thinking about different kinds of evidence. One possibility is gravitational lensing. According to Einstein's theory of gravity, mass bends space itself. When light from a distant star passes near a very massive object, that light doesn't travel in a perfectly straight line. Instead, it follows the curved shape of space around the object. The result is a tiny distortion. A distant background star might briefly appear brighter, or its apparent position might shift ever so slightly. It's almost as though the invisible object acts like a cosmic magnifying glass. Astronomers have already used this technique to discover otherwise invisible objects throughout our galaxy. Perhaps one day it could reveal something hidden much closer to home. Then there's an even stranger possibility. Some physicists have suggested that if dark matter exists as certain hypothetical particles, those particles might collect around a primordial black hole over billions of years. If enough of them gathered together, they could occasionally collide and annihilate one another, producing bursts of high-energy gamma rays. In other words, we wouldn't be seeing the black hole itself, we'd be seeing a glowing cloud of exotic particles surrounding something that's completely invisible. Now, to be clear, none of this has been observed. No primordial black hole has ever been confirmed. No mysterious gamma-ray beacon has ever been linked to one, and Planet 9 itself remains hypothetical. And this is science working exactly the way it's supposed to. Someone has a theory, and science asks the hard questions. Whether Planet 9 turns out to be a distant ice giant, a primordial black hole, or nothing at all, the search itself is teaching us new ways to investigate an invisible universe. New observatories like the Vera C. Rubin Observatory, which just came online last week, will repeatedly photograph the entire southern sky, creating an unprecedented time-lapse record of the universe. Tiny changes in the positions and brightness of millions of objects may reveal clues we've never had before. Space telescopes continue mapping the motions of stars with extraordinary precision, while high-energy observatories keep watch for mysterious bursts of gamma rays. Gravitational lensing surveys search for objects that reveal themselves only through their gravity. None of these observatories were built specifically to find primordial black holes, but they may be exactly the tools that finally tell us whether such objects exist. Maybe someday those observations will reveal a massive planet hiding in the darkness beyond Neptune. Maybe they'll tell us there's nothing there at all. Or maybe they'll uncover something stranger, a tiny relic from the first fraction of a second after the Big Bang, quietly orbiting the sun for billions of years without reflecting a single ray of light. Whatever the answer turns out to be, it's a comforting reminder that we still don't know everything about our own cosmic neighborhood. Out beyond the familiar planets, there are still blank spaces. And history has shown us that blank spaces on a map are often where the greatest discoveries are waiting. Now let's take a look at what's happening in the night sky over the next couple of weeks. The big headline this period is the moon. We'll begin under a waning moon, which means darker skies return with each passing night, culminating in the new moon on Tuesday, July the 14th. That's the best opportunity this month to hunt down faint galaxies, nebula, and the rich star clouds of the summer Milky Way. If you have access to a truly dark location, take advantage of those moonless evenings around July the 13th through the 16th. The Milky Way stretches dramatically from the southern horizon through the summer triangle overhead, making this one of the finest times of the year simply to lie back in a lawn chair and soak in our galaxy. Speaking of the summer triangle, Vega, Deneb, and Altair now dominate the evening sky. If you're looking for a challenge with binoculars, scan the area between Cygnus and Vulpecula for the famous coat hanger asterism, a delightful little pattern that isn't actually a star cluster but always seems to surprise first-time observers. Turning to the planets, Saturn continues to improve in the pre-dawn sky. Look toward the east after midnight or before sunrise, where the ringed planet shines steadily above the horizon. On the mornings of July 7th and 8th, a waning moon slides close to Saturn, creating a beautiful pairing that's easy to spot with the naked eye. Nearby, you'll also find Mars and the Pleiades star cluster joining the scene before dawn. If you have good binoculars or a telescope, look between the Pleiades and Mars to find Uranus. Mars itself is still fairly modest in brightness, but it's slowly climbing into a better observing position as we move through the second half of the year. If you're up before sunrise, it's worth following its progress from week to week. Jupiter, our companion through the winter, spring, and early summer, has wandered across the sky and now joins Mercury close to the setting sun. Both will be virtually impossible to spot during this period. As we approach the new moon, keep an eye on the western horizon after sunset. On July the 17th, a razor-thin crescent moon appears alongside brilliant Venus, creating one of the prettiest naked eye sights of the month. Bring along a pair of binoculars and you may even notice Earthshine, that soft glow illuminating the moon's dark side, caused by sunlight reflected from our own planet. Deep sky observers should make the most of these moonless nights. This is prime season for the Great Hercules cluster, M13, one of the finest globular clusters in the northern hemisphere. Just east of it lies the Ring Nebula in Lyra, a favorite target for small telescopes. Farther south, the rich star fields of Sagittarius are packed with open clusters and glowing nebula waiting to be explored. Meteor activity is beginning to wake up as well. The southern delta Aquarids officially become active around July the 12th, although their peak won't arrive until the end of the month. You might catch an early meteor or two during the dark, moonless mornings after the new moon, which is a nice preview of showers later this summer. That's going to do it for this week. If tonight's episode sparked your curiosity or maybe gave you something to think about the next time you look up, I'd be honored if you shared star trails with someone who might enjoy the journey. You can always find the latest episodes, show notes, and extras at startrails.show. And if you'd like to help support the show, there's also a little Buy Me a Coffee link on the site. That genuinely helps keep these stories coming. Be sure to follow Star Trails on Blue Sky and YouTube. Links are in the show notes. Until we meet again beneath the stars, clear skies, everyone.